Hello Professor, my name is Gautam and I will be explaining the second problem of the homework 3. Now it is given that x is uniform in the interval -1 to 2 and y is equal to x square. Therefore we can say that the density function can be given by 1 upon b minus a, that is equal to 1 upon 2 minus minus 1, that is equal to 1 by 3. Therefore the graph of f of x will be uniform in the interval -1 to 2 having a magnitude of 1 by 3. Now we have to find the distribution function, that is capital Fx of x, and we can say that it is equal to the integral in the interval 0 to x of the density function. Therefore that can be given by x minus a upon b minus a. Therefore we get the value of fx of x as 1 by 3 x plus 1 by 3. Now when we plot the distribution function, we get a ramp function in the interval -1 to 2 having a magnitude intersecting the y-axis at 1 by 3 with a slope 1 by 3 and having a value of 1 after the range 2. Now in the b part we have to find the density function of y. Now it is given that y is equal to x square, therefore it will be a parabola, that is -1 to 2 in the interval -1 to 2, and this is the curve, that is y is equal to x square. Now since in the interval 0 to 1 y can take two values, therefore we can say that fy of y is fx of x1 upon magnitude of g dash of x1 plus fy of x2 upon mod or magnitude of g dash of x2. Therefore g dash of x2 will be 2 root y and g dash of x2 will be 2 root y, and when we take the mod we get 1 upon 6 root y plus 1 upon 6 root y, that is equal to 1 upon 3 root y. Now in the interval 1 to 4 we will have only one root, that is 1 upon 3 root y, 3 into 2 root y, that is equal to 1 upon 6 root y. Now when we plot the graph we get a function like this, the graph, and at y equal to 1 the value will be 1 by 3 and y equal to 4 we get the value as 1 by 12. Therefore the graph will be like this for the density function fy of y. Now we have to find the distribution function of fy of y. Therefore now since we have already calculated the value of the density function, now we will again integrate it in the different intervals, that is from 0 to 1 and again in the interval from 1 to 4. We get the value of y in the interval 0 to 1 as 2 by 3 root y, and in the interval 1 to 4 we get the value as root y plus 1 into 1 by 3. Therefore the value of the distribution function will be 2 by 3 root y u of y minus 1 plus 1 by 3 root y plus 1 u of y minus 1 minus 1 by 4. Now the graph of the density distribution function will be an increasing curve in the interval 1 to 4 and it will be constant after 1. Now we have to find the expected value of y, and since we have already calculated the density function fy of y, we substitute the values as found from the previous sub question, that is we got the value of y as 1 by 3 root y in the interval 0 to 1 and 1 by 6 root y in the interval 1 to 4. Now when we calculate that, we get the value as 1 by 3 y to the power 3 by 2 upon 3 by 2 interval 0 to 1 plus 1 by 6 y to the power 3 by 2 over 3 by 2 in the interval 1 to 4, and when we simplify this we get the value as 2 by 9 plus 7 by 9, which is equal to 1.